The kitchen robot industry is lying to your face. Right now, every tech outlet is fawning over the Posha cooking robot like it is the second coming of the microwave. Slick demos, beautiful renders, a promise that you will never chop an onion again. And nobody, not one mainstream voice, is asking the obvious question. Can this thing actually work in your kitchen, on your food, with your chaos? Let me tell you who the villain is here. It is not Posha specifically. It is the entire consumer robotics hype machine that keeps recycling the same playbook. Show a curated demo in a controlled environment. Film it from the one angle where the gripper does not fumble. Raise $100 million. Repeat. We saw it with Moly Robotics years ago. We saw it with countless other startups that promised autonomous cooking and delivered glorified convection ovens with arms. The pattern is clear, and in my analysis, Posha appears to be walking the exact same path. The underlying technical barriers have not gone away just because the marketing got prettier. Here is the proof, and I have 3 points that should make anyone with engineering sense very uncomfortable. Point 1. The inference bottleneck. Cooking is not pick and place. A warehouse robot grabs a rigid box from point A and drops it at point B. A cooking robot needs to handle soft, deformable, wet, sticky, slippery objects that change shape and texture in real time. Every single grasp requires a fresh inference pass through a vision model, and the latency budget is brutal. You are working with hot oil, boiling water, items that go from raw to overcooked in seconds. Current edge compute hardware at consumer price points simply cannot run the perception action loops fast enough to handle that. We are talking about needing sub-100 millisecond response times for safety-critical manipulation, and the models that could deliver that do not fit on the chips that could hit a consumer price tag. Point 2. The sim-to-real gap. Every impressive cooking robot demo you have ever seen was almost certainly rehearsed in simulation first. The robot learns in a physics engine, then transfers those learned weights to the real hardware. The problem is that food does not simulate well. The physics of dough stretching, oil splattering, a piece of fish flaking apart, these are chaotic, non-rigid body dynamics that no current simulator reproduces faithfully. So the robot works perfectly in the demo kitchen, where every variable has been controlled. And then it meets your misshapen sweet potato, and your dull knife, and your wobbly cutting board, and the whole policy falls apart. The sim-to-real transfer gap for unstructured kitchen environments remains, in my analysis, one of the hardest unsolved problems in all of robotics. Point 3. The fine-tuning economics. Let us say you want this robot to cook 1,000 recipes. Every recipe is essentially a new task distribution. You need demonstrations, you need reward shaping, you need hours of real-world rollout data per dish. Fine-tuning the underlying vision language action model for each new recipe is expensive. Scaling that to the 10 or 20,000 recipes a real consumer would expect is economically insane at any price point under $50,000. The math does not work, and no one shipping these products is being transparent about that. If you are the kind of person who sees through the demo reels and wants the actual engineering truth, subscribe. We are not slowing down, and this industry needs more people paying attention. Now, the counter-argument. People will say the technology is iterating fast, that foundation models for robotics are improving month over month, and that what looks impossible today will be table stakes in 3 years. Fair point. I actually believe general-purpose robotic manipulation will get dramatically better. But here is the thing. Better does not mean consumer-ready. The gap between a research lab cooking a single omelet under supervision and a product that reliably cooks dinner for a family of 4 every night for 5 years without maiming someone is enormous. It is not a software update. It is a fundamental shift in reliability engineering, in FDA-level safety certification, in supply chain robustness for actuators and sensors that will be exposed to grease and steam and heat daily. Calling a prototype a product is not optimism. It is malpractice. So here is where I land. The Posha cooking robot, and every kitchen robot like it, appears to be selling a vision that is at least a decade ahead of the actual engineering. The demos look magical because they are supposed to. That is their job, Your job is to ask what happens when the camera turns off. So tell me, would you trust a robot to cook dinner for your family tonight? Yes or no?